Welcome to Mrs. O's Math World. So this part we're going to discuss how to use the informations to handle examples. Alright, so in this session we will need 4 important tools on hand. So the first one is we need to check whether it is type 1 or type 2 for the identities. And then the second thing is how to check the quotients. The third thing is how to change the trigonometric identities if it is on type 2. And finally, how to check with the quotients. So let's move on to page 10.14 for examples. Okay, so let's try to move on to simplify the expression. Okay. So for part A, right now you can see that we have different sorts of degree, and then we need to check it out carefully for the corresponding quotients. So I've written down the angles so that I can check it out carefully for the corresponding quotient. So for example, 270 degrees plus theta, quadrant 4, and for minus, quadrant 3. Okay, because the theta, you just imagine it's just a little bit. And for cosine, it goes a little bit also. And then, because all these are of type 2, so we need to do the changes like cosine goes to sine, sine goes to cosine, and then tangent goes to 1 over tangent. Okay, so after we change all these, so you can see that sine changed to cosine, cosine changed to sine, and then tangent goes to 1 over tangent already. And then how to check the positive or negative? So it depends on the original ratio. That means for the upper one is sine in quadrant 4. So we check this. It should be cosine to be positive, right? So it means it is sine, and then we check equals to sine, right? For the sine, that means it goes to negative. Okay, bear in mind that we always check for the original one. Then let's move on to the rest. So for the next one, you can see that we are handling for tangent. It is comparatively easier because we just changed the tangent to 1 over tangent, and then it is still tangent. So for quadrant 3, this is positive. And then it goes to the last one, which is cosine in quadrant 4. Okay, so cosine in quadrant 2, cosine in quadrant 2. And then cosine in quadrant 2 is negative. Great. This is the most difficult part. Bear in mind that we always check it out for the original trigonometric ratio. And then we just need to simplify to get the answer. So you can see that for the final answer, it is 1. Right now, let's move on to part B. So for part B, you can see that actually some of them are of type 1. For these two examples, and then these two trigonometric ratios are of type 2. Okay, so make sure when you're doing the question, please make sure you really understand whether we need to change the ratio or not. Alright, so you can see that for type 1, that means cosine 180 degrees plus theta and sine 360 degrees minus theta, so they have no need to change the ratio. And then we check the sine one by one by using the CAST. Okay. And then for sine 90 degrees minus theta, quadrant 1, right? We change some sine to cosine, and it is positive. Just keep it. And then finally for cosine 270 degrees minus theta, this is in quadrant 3. And don't forget to change from cosine to sine. And then simplify, this is 1. And this part becomes negative cosine square theta. And we make use of this identity to change it for sine square theta. So which is the simplified answer. Okay, remember when we calculate this kind of question, we simplify, we always handle the degrees first. That means if the number is 180 degrees and so on. For the final answer, we can only have theta as a simplified version. Okay, so we shall move on to one more example, which is about proving identities. So let's move on the example 10.15. So you see that for this example, we're going to prove these trigonometric identities. And then for both parts, we can see there are some troublesome stuff. That means we need to convert them to the acute angle version. Okay, so we need to do them separately for left-hand side and right-hand side. So please check on the quotients of all these one by one. Okay, so right now we work it out one by one. So for the upper one, you can see change to sign, but of course quadrant 4 is positive for cosine. And then tangent, we get quadrant 3 to be positive also. So I write it on positive sign, which is easier for reference, okay? So you can see that I put down the brackets for, okay, by purpose, because it's very important that it is a multiplication instead of a addition, right? And then we simplify for the trigonometric ratios because sine over cosine becomes tangent. So we get tangent divided by tangent, which is equals 1. So we also work it out similarly for the right hand side. So for right hand side, this part you've got a square. Okay, so please pay attention on how to handle the square. So I handle the square with putting it for bracket outside. Because it is just for convenience to put it in the middle. It should be the whole thing square. So sine becomes cosine because it's type 2. And then for quadrant 3, sine is negative. And for quadrant 4, it is just have a tangent because it is also 360 degrees minus theta. No need to change. But it is quadrant 4, so it is negative. And then we simplify, you can see that it becomes cosine square minus tangent square theta. And then using the trigonometric identity again to simplify the expressions so we can get the answer to be 1. Alright? As a kind of identities, finally, don't forget to calculate state that they are equal for left hand side and right hand side because they are both equals to 1. And then to save time, you can just write it is an identity. Okay, so that's the end for this session. See you next time.